Okay, today on Math with Malia, we're going to do the Eureka squared, Math 7-8, Module 5, Lesson 19, Volumes of Pyramids and Cones. We've already learned how to do the volume of prisms using the area of the base times height. So today we're going to compare the volume of prisms to pyramids and cones so we can develop the formula for these three-dimensional shapes. Just a review of how to calculate area, since we're going to need to calculate the area of bases. If we have a rectangle, remember area is just length times width. So that's how we got 60 is multiplying by 12 times 5. Area of a circle is pi times the radius squared. So we square 4 and multiply it by pi. Is how we get 16 pi for the area of the circle. Area of a triangle, remember, is 1/2 the base times the height. So we would do 1/2 7.5 times 6.2 to get an area of 23.25. And area of a trapezoid, there's multiple ways you can do this. You can divide it into a square and a triangle. And then remember that we can figure out the length of the triangle or the base of the triangle, and the height would still be 4, and we could combine the two areas. Or if you remember the formula for area of a trapezoid, it is 1/2, since we are dealing with a trapezoid or a triangle side, 1/2 times the sum of the bases times the height. So if we plug those numbers in, we can just use 13 plus 8 times 1/2 times 4. So what do we think the relationship is between the volume of the right pyramid and the volume of the prism? When we saw how the volume compared, we saw that the pyramid only held 1/3 of the volume of the whole prism. So we can say that the volume of the pyramid is equal to 1/3 times the volume of the whole prism. We saw that in the video. So no matter what the shape of the base is for the pyramid or the prism, as long as they have the same base and the same height, then we know that the volume of the prism is going to be 3 times the volume of the right pyramid, because the pyramid does not take as much space as the prism. So here's just a review of how we say volume units. We say cubic inches, or it can be abbreviated with inches with an exponent of 3. And remember, since in volume we are multiplying 3 dimensions, we're multiplying the length and the width and the height. That's why our units are cubed. If our units are squared, as in square inches, that means we're just dealing with 2 dimensions, so we're going to be measuring area when we have square units. Okay, so we know from previous lessons that the volume of a right prism is the area of the base times the height. So what formula can we develop for the area of a right pyramid, knowing that our pyramid is 1/3 the volume of the prism? Okay, so the volume of a pyramid, it's going to be related to the volume of the prism, but it's only 1/3 of the volume. So we need to multiply our volume for the prism, which is capital B times H, and divide it by 3, or multiply it by 1/3 to get the volume for any pyramid, any right pyramid. So here's our formula for volume of a right pyramid: 1/3 the area of the base times the height. And remember, we're going to substitute capital B for whatever area the base is. If it's a circle or a triangle or a pentagon, we will substitute that formula for that specific base. All right, let's talk about cones. A cone is similar to a pyramid in that it has an apex, it has a flat base, but it's not the same as a cylinder. I'm going to draw what it would look like in a cylinder. Okay, if it had the same radius, the same diameter, the same height, you can see that it doesn't take up as much space as the whole cylinder does. So what do you think the relationship is between the cone and the right cylinder? Okay, so the parts of a cylinder, we have the point, and just like with a pyramid, this point is called the apex. We have the line segment that goes to the center of the base, and it is perpendicular to the base. So the height of any prism or three-dimensional object is going to be perpendicular to the base. So there's the height of the cone. And then we know that the section, the line segment from the center of a circle to the outside, is the radius of the circle. And we can use that to calculate the area of the base. So here's a review of oblique prisms versus right prisms. An oblique prism is when it looks like it's slanted. The height is not, the diagonal lines, the outside of the prism is not perpendicular to the base. And we know that height always has to be perpendicular to the base. When we measure prisms, the height will always be perpendicular to the base. So if it is an oblique prism, then we will see the height designated with a dotted line perpendicular to the base. And you can see that either inside the prism or outside the prism. So they have the same circumference, the same diameter, the area of the base will still be the same, and they have the same height. We're going to compare the volume of the cylinder to the volume of the cone. And we're going to place the cone inside the cylinder to displace or push out water from inside the cylinder. How much water got displaced? We're going to actually measure then how much water is left in the cylinder. So 1 cone worth is still left in the cylinder. And a second cone's worth is still left inside the cylinder. So if 2 cones worth of volume is left, that means the cone displaced 1/3 of the volume. All right, how can we come up with the formula for the volume of a cone? We know the volume of a cylinder is area of the base times height, and since the base of our cylinder is a circle, we can substitute pi r squared for capital B in our volume formula. So the volume of a cylinder is pi r squared times the height of that cylinder. Now, if it's a cone, we remember that the relationship between a cone and a cylinder is that the cone only takes up 1/3 the volume of the cylinder. So how would we change our volume of a cylinder formula to represent the volume of a cone? Well, we would need to multiply that volume, pi r squared times height. We would have to multiply that volume of a cylinder by 1/3 to get the volume of a cone. So there's our formula for volume of a cone, 1/3 pi r squared times the height, and we're going to use that formula to calculate volumes of different cones. Here's our first one. What do we know so far? We know the radius, so let's label the radius is 1.5. And this diagram gives us the height, so let's label the height is 4. We've labeled what we know. Now let's write the formula we're going to use. Since it's a cone, we're going to use the formula 1/3 pi r squared is the area of the base times the height. Now let's substitute the values that we know. 1/3 times pi. Instead of r, we can substitute 1.5 squared. Instead of h, we will substitute 4. Okay, and we can keep calculating. 1/3 pi, 1.5 squared is equal to 9 times 4. Sorry, 1.5 squared times 4 is 9. And 9 times 1/3 is 3. So our volume of the cone would be 3 pi centimeters cubed. So here we're going to be exploring how height is related to the apex of a three-dimensional shape and how that relates to the volume. So here we have an oblique cylinder. The radius is 2, the height is 6. If I move that apex around, the height is still 6, the radius is still 2. It's not changing the volume, no matter where I move the apex. So the space inside the cone does not change, even though the apex is changing position. And we can do this the same with a pyramid. Okay, the height is still h. It is always perpendicular to the base. So no matter where I move the apex, the height is still going to be 6. And the area of the base will still be 4 times 4. Okay, let's calculate some more volumes. Number 8, what did they tell us? Well, they told us the height is 4. And they told us the area of the base. So we know capital B is 12. So what formula can we use that uses capital B and H? Well, that's just our original volume formula. Volume equals capital B times H, the area of the base times the height. But it's a pyramid. So how do we change our formula to represent a pyramid? Well, don't forget to add multiplying by 1/3. Now we have our correct formula. Let's substitute our numbers so we can calculate the volume of this pyramid. 1/3 times 12 times 4. 1/3 times 48. The volume would be 16 centimeters cubed. Okay, number 9. Let's see what the diagram gives us. We know the diameter is 18, so can we figure out the radius? Yes, we know the radius would be 9. And they gave us this diagonal length. This is not that length that is perpendicular to the base. They gave us the length of that side. If we look carefully, we can see that inside this cone there is a right triangle. So on this right triangle, I know the hypotenuse and I know one leg of the triangle. What formula can we use when we know two sides of a right triangle? Well, we can use the Pythagorean theorem. So we're going to write our Pythagorean theorem formula and then substitute the values that we know. Let's say side A is 9, so we'll say 9 squared plus B squared, and our hypotenuse is 41. So 81 plus b squared equals 1681. We subtract 81 from both sides. B squared equals 1600. And to solve for b, I'm going to take the square root of both sides. B equals 40. So now we know the height of our cone. It is 40. Did we answer the question yet? No, we still have to calculate the volume. So let's write the formula for volume of a cone. Volume equals 1/3 times pi r squared times h. Now we can substitute the values that we know. Volume equals 1/3 times pi. The radius is 9 squared, and the height is 40. And if we do all those calculations, we will get 1/3 pi times 3,240. Divide that by 3. Our volume will be 1,880 pi. I'm going to leave it in pi notation so I have the most accurate answer. And these are inches cubed. Number 10, what is the volume of this right pyramid? So what do we know? We know the length of the whole side. Can we figure out that section? Yes, we know that section would be 9. And again, they gave us the diagonal line segment, so we're going to need to use our Pythagorean theorem again to find the height of the pyramid. Okay. So we know this section would be 9. It's half of the whole length of the side. So a squared plus b squared equals c squared. It looks like we're going to be using the same numbers as we did in the previous problem. 41 squared, so 81 plus b squared equals 1681. Subtract 81 from both sides. B squared equals 1600. Take the square root of both sides. B equals 40. So the height of this pyramid is 40. Okay, and now let's figure out what formula we're going to use for volume of this right pyramid. Volume is the area of the base times height. And since it's a pyramid, don't forget we have to multiply by 1/3. Okay, so volume equals 1/3. What is the area of our base? It is a square. Area of a square is just the side length squared. So we're going to take 18 and square it. Or, there we go, length times width. And the height of our pyramid is 40. When we do all those calculations, we get a volume of 4,320. Don't know the units, so we can just say units cubed. Okay, we've got a couple more problems to calculate. The volume of an oblique cone, okay, so we know it's not a right cone, is 192 pi cubic feet. So let's write that down. We know the volume, or V, equals 192 pi. The diameter of the base is 24. So I know the diameter is 24. What is the height? I'm trying to solve for height. So let's think, what is our formula for a cone? Volume equals 1/3 the area of the base times the height. And the area of the base, since it's a cone, will be 1/3 times pi r squared times height. If I know the diameter is 24, can I figure out the radius? Yes, the radius is just half the diameter. Okay. So let's plug in numbers into our formula so we can solve. I know the volume is 192, so instead of V, I'm going to substitute 192 pi equals 1/3 times pi, and instead of r, I can substitute 12 squared. We are solving for h, so we're going to divide both sides by pi. So those will cancel out. And then we need to multiply by the reciprocal of 1/3, so we're going to multiply both sides by 3. And then we would need to multiply by 12 squared, or sorry, divide by 12 squared. So what we're going to do, the pi canceled on both sides, so we will do 3 times 192 and divide it by 12 squared. When we do all those calculations, we get a height of 4. feet. Okay, last problem. A rectangular pyramid has a height of 10 centimeters. I'm going to write that down. Height equals 10. And a volume of 160 cubic centimeters. Volume equals 160. The length of the base, so I know the length is 12 centimeters. Find the width. I'm looking for the width. Okay, so now let's write the formula that we're going to use. Volume equals, since it's a pyramid, I'm not going to forget to multiply by 1/3. 1/3 the area of the base times the height. If it's a rectangle-shaped pyramid, then I know the area of the base will be length times width times height. Let's substitute the numbers that we know into our formula. Volume is 160. 1/3 times the length is 12 times W that I don't know times H, which is 10. And now we just have to use our property of equality to solve for W. First, we can multiply both sides by 3. And then we're going to divide both sides by 12 and divide both sides by 10. So that's really just dividing both sides by 120. Okay, and so that will cancel, that will cancel, that will cancel. That will leave us with W all by itself. And when we do our calculations, then the width would be 4 centimeters. So how does the volume of a right pyramid compare to the volume of an oblique pyramid with the same base and height? Well, the volume will be the same. Remember, the height is perpendicular to the base, so the height will be the same even though we might see the height measured from outside the oblique pyramid. How does the volume of a right cone compare to the volume of an oblique cone with the same base and height? Again, just because it's oblique and slanted slightly, I didn't take any space away. I've just moved it a little bit. So the height would still be the same, even with the oblique cone. So the volume would be the same. What is the relationship between the volumes of a pyramid and a prism with the same base and height? So thinking back to our videos, we know that the volume of a pyramid is always going to be 1/3 times the volume of the prism that has the same base and the height. That's important. It has to have the same base and the same height for that relationship to work. How is the relationship between the volumes of cylinders and cones like the relationship between prisms and pyramids? Well, they're both that relationship of 1/3. The cone is 1/3 the volume of the cylinder. A cylinder is like a prism, and a cone is like a circular-based pyramid. I hope you had a good time with math today. Make sure to leave a comment if you have any questions and come back for more videos and help with your math.